Hello everyone, let's take a look at our next problem. Given that x1 equals 211, x2 equals 375, x3 equals 420, x4 equals 523, and xn equals xn minus 1 minus xn minus 2 plus xn minus 3 minus xn minus 4, find the value of x531 plus x753 plus x975. Okay, goodness. I mean, you can see on the screen this crazy recursive relation we're given, and we're just asked to compute some arbitrary term. So first thing that comes to mind is there's got to be, I'm assuming there's going to be some kind of pattern in the numbers that repeats like every 2 numbers or every 4 numbers. You know, notice that the recursion relation has alternating signs in it. I'm tempted to start by computing the first few numbers in this relation. On the other hand, we might also have some kind of telescoping thing going on here. So for example, let's start with the recursive relation itself. And I'm going to compute, what do I want to compute here? xn plus 1. Or do I want to just... Okay, what I'm going to do is I'm going to use the recursive relation itself to substitute what xn minus 1 is equal to. You know, let me write it down here so we can see clearly that xn minus 1 is equal to xn minus 2. Right? This is just taking the relation we're given and substituting the index n minus 1 for n everywhere. And so now, whoops. My first equation, if I make this substitution, we have that in parentheses is xn minus 1. Yeah, okay, so the way this works is the sequence repeats every 5 digits, or every 5 terms it repeats, but with alternating sign. Let me just make sure I did this all correctly. Yeah, this should work. So if I subtract multiples of 5, okay, so I think okay, so x531, we're asked specifically about, this is one of the 3 terms in the sum that we have to compute. This is going to be equal to x1 with a potential plus or minus in here. Okay, so I guess it'll be positive because I subtracted an even number of multiples of 5. And going from 531 down to 1, I've subtracted 530. So I've done this minus 5 thing an even number of times. x753, this is going to be equal to x3 for similar reasoning. x975 is going to be equal to x5, which we haven't computed yet. x5 is equal to x4. Okay, so I should have everything I need here. Okay, so I get the answer is 898. And unless I made some arithmetic mistakes, I'm fairly confident in this answer. The key here, I suppose, was really doing this step. when you're given a sequence defined in terms of a recursion like this, it's nice to substitute the recursive relation itself back into the recursive relation just to see if some kind of pattern emerges. And the pattern here came out with the fact that there was tons of cancellation between terms. And so we see that the sequence itself just repeats itself every 5 terms except with a sign change. And even that sign change didn't really end up mattering at all because you know, I have to subtract a multiple of 5 from this an even number of times to get down to 1. Same thing with this 753 to get down to 3, 975 to get down to 5. If we were asked, for example, for the number x 536, well, x 536 would be negative 211, and that comes from this. Yeah, so 898 I'm fairly confident with. If I find a mistake or have more to say about this one, I'll put it down in the description. Thanks for watching.